Hi, I'm Justin. I'm a senior software engineer at General Magic, the makers of Magic Earth, the free navigation app, which has turn-by-turn navigation that works with offline maps. So there's maps for over 200 countries that can be downloaded for offline use. So no internet connection is required to compute a route and to navigate along that route once you download it and installed the maps for the regions that you intend to travel. The application uses OpenStreetMap data. It has 2D maps and also 3D maps with topography and satellite imagery and lots of map styles for day and night and many voices, so many languages to choose from. And all these features are now also available in the General Magic QML plugin, which Bogdan wrote. And I will be presenting in this presentation.
Okay,
Bogdan?
I'm Bogdan Vatră. I'm coding for KDAP, and besides all the cool stuff that we already do, like Qt and OpenGL and Clazy and other Hotspot and other cool stuff, we decided to join our forces with General Magic and to create wonderful QML plugin for maps, but not only maps. You'll see that we have many other features like routing and navigation. Sadly, this video was not big enough to fit all the features, so we only present you just 3 of them. Of course, if you check the website, generalmagic.com, you will see many more features there. And having said that, I think we are ready to play the video. So, DJ, play the video.
In this presentation, we are going to write a navigation app using the General Magic QML plugin. We go here to Developers. Now this layout may change in the future. Installation instructions, and we see that the easiest way to install the QML plugin is using the Qt maintenance tool. We see here 3 repositories for Linux, Mac, and Windows platforms. Now this is the platform on which we are developing, not our target platform. In this case, we select the Linux one because we are on a Linux desktop here. We start the Qt maintenance tool. We go here to Settings, Repositories, User-defined repository, Add, and we put it here. Test. The repository was tested successfully. Great. Okay. So next. Add or remove components. Now it's getting the component list from the server. We open here Qt. We see that the Qt version which we have installed is 5.15.2. So we open KDAP and General Magic, and we want to select the exact same version of the General Magic plugin, 5.15.2. We expand that, and we see we have several platforms supported here. We definitely need to get the Linux desktop because we are on a Linux desktop. And let's also get the Android and the embedded ARM64. Great. Next, we agree to the license. And now its setup is ready. Update. Now, while the QML plugin is downloading, it is also installing the documentation and the examples. And the documentation will be visible inside the Qt creator. We have a context help, so we can press F1 on any type, and we see the help. Great. It's installed. So now we can start the Qt creator and start developing. There it is. We go here and create a new project, a Qt quick application empty. We choose that. We'll just call it quick nav and just choose all the default settings, nothing special here. Great, there it is. Now, the first thing we want to do is import the General Magic QML plugin. we're going to write a navigation app. So make a plan. Navigation app contains three main parts. The first part is mapping. Mapping refers to a control which displays the map and supports functionality such as pan and zoom. The second part is routing. Routing refers to having at least 2 points on the map, a departure point and a destination point, and optionally additional waypoints in between, one or more, and computing a route between the departure and the destination point, and then draw it on the map. The third part, navigation, refers to a journey along this route which we have computed and drawn on the map, and this journey can be real or simulated. Great. So now that we have a plan, we start. The first part is mapping. So we start with a map view component. There it is. And just give it a name, let's say map. And we should also open the context help for it. We see that. And we want our map view component to fill the entire window. Great. So with just 3 lines of code, we should have a map. Let's see if it works. And there it is. We can pan, we can zoom, but as we zoom, we see that there's no additional details. The reason for this is because we have a hybrid engine. It works with both online and offline data. So it does not require an online connection to work. So we need to specifically tell it to connect to the server and download the tiles for the area we want to show, because we don't have any maps installed here. So we have the component on completed signal. And here we say services manager, common settings, allow internet connection, and we set that to true. Great. Let's see if that works. So now when we zoom in, we see that more and more details appear. There we go. Tiles and other map elements are downloading. So while we are here, we're also going to change the name of the application to QuickNav. And we should also mention that this is where we would put our token, which is a services manager common settings token. So you see the context help for that. So here in the context help, we see the general magic QML getting started guide shows how to create an account. We just need to put an email and create a password, and then we make a project, and then we get an API key. And here at the bottom, we have our API key. We can just click this button to copy it, and theoretically we could just put it here, but we don't want to do that. We want to keep our key safe. So we will put it here in the main CPP file and define it as a CPP property. This is shown how to do this in the example, so we won't worry about this right now. Just pointed it out and just comment this out for now. Great. So now that we have our map, the next step is routing. So we have a routing service. Just give it a name ID routing. Pull up the context here for that. There it is. So we want to know how are we going to compute our route. We want the fastest route or the shortest route, for example. So we go here, route type fastest. And what type of route do we want for transport mode? We could have different types of transport modes. We could have a transport mode for a footpath or a bicycle path, or public transportation, or lorry or truck path, or car. So let's just select car. Great. Now the most important part of a route is, of course, the waypoints. We have here a landmark list, which is a list of landmarks, and each landmark contains coordinates. So the first landmark is going to be our departure point. We need to have at least two, the departure and the destination. We call this departure. And we give it coordinates. Latitude. And longitude. Now this is in Paris, because even in pandemic times it's not possible to have virtual restrictions, so we could always have a virtual dinner in Paris. And now we're gonna put our destination landmark. There it is. Just call it destination. Okay. And now that we have our waypoints defined, what do we do when the computation of the route is finished? So we have our unfinished signal. So when the route is computed, we want to tell the map about it. So we will give our route to the map. Route collection, set, route list. Now, when we compute a route between our departure and destination, we actually get a route list. We don't get just one route. We get a route list because there could be multiple routes, alternate routes. And then we want to center on this route list. So we want to fly the camera to these routes such that all of them will fit in our viewport. Great. Now, we could trigger the route computation as soon as the application is started, but that would be boring. So we want to let the user decide when to compute a route. So for that, we're going to add a button to the map view here. You see the button is red. It's because we need to add here an import. The quick controls, which is pick the latest one. Great. So this button, let's put it on the lower left corner of the map. So we anchor it to left, parent left, bottom, parent bottom. And let's not put it right on the edge. Let's give it a margin, like 5 pixels off the edge. And the text that we're going to write on the button is going to be, of course, compute routes. And when the button is clicked, we get this on-clicked signal. And that's when we go to our routing component and call it update function. Great. Now let's see if this works. There's our map. There's our button. Click. Routes are computed and the camera flies to them and all of them fit in the viewport. Now, we see that we have 2 alternate routes. We can click on them, but we cannot select them. So let's make it possible to select them. In map view, we have our on route selected signal. So we go to our route collection and we set our main route to the route that we just selected. and then we fly the camera to that route. So we don't fly to a route list, we fly to one route, to our main route, which we just selected. Okay, so let's try and see if this works. Compute routes, fly to the routes, select the second one, we fly to it and center it, the third one, first one. Great. So now the user can select whichever route they want. Now that we have both mapping and routing, the next part is navigation. So for navigation, we have a navigation service. The context, okay. We just give it a name, navigation. And the most important part for the navigation is, of course, the route. Here we have exactly one route, the one that we already selected for navigation. And since we already have it, we get it from the map. Route collection, main route. Our navigation service can navigate a real journey or a simulated journey. In this case, it's going to be simulated. It's a virtual journey. So we set simulation to true. In the case of simulation, the simulator generates GPS positions similar to those from the GPS device. So we have our on active changed signal. This is very important. We have the active property of the navigation service, and we check it. So if the navigation is active, that means that this active property is true, then what we want is to start following position. And the reason this is important is because during navigation, the position indicator is moving. So if the map is not moving, then the position indicator will move off the map and off the screen. So we want the camera to follow the position indicator while navigation is active, and therefore it is moving. So we start following position, and we also want to clear our route collection and put just the main route. So this route here is our main route because we just defined it up here. We set it there. And that's the only route we want to see on the map while we're navigating, because we already decided which of the possible alternate routes we want in case there's more than one. Okay. Now, we also have another signal here. Important signal is on destination reached. We want to know when we reached our destination. We go to route collection, clear. So when we reached our destination, we want to no longer show the route on the map because we're finished. We are at our destination. And then we have on navigation route updated. Now this can happen if we travel off the route, like maybe we take a detour, and in that case the engine will detect that we moved away from our route, and it will calculate a new route to our desired destination from our current position. And in that case, again, we want to clear the existing routes, and we want to add the newly calculated route to the route collection. So we have just one route on the map while we're navigating. Great. Now, we want the user to decide, once the route is computed and drawn on the map, when to start navigating. So again, we go to map view and we add another button. There it is. So this button is going to be, let's put it in the right bottom. Okay, also not right at the edge. And if navigation is not active, we want to start it. If it is active, we want to stop it. That way the user can toggle the navigation on or off and thus control it. So we'll say if navigation is active, that's the navigation property there. We'll say stop navigation. Otherwise, we'll say start navigation. Great. So when this button is clicked, we just want to toggle it. Navigation active equals not navigation active. Great. Now let's see if this works. So there's our compute routes. Fly to the routes. We have the main route is selected from the departure to the destination point. It's auto-selected. The first route, the second one, and the third. And then we can start navigation.
After 250 meters, turn slightly right.
Great. It works. Okay. Now, while this is navigating, we can want to see, for example, an icon of that shows us the next turn. So let's do that. We go here to map view. We make here a rectangle. We also want to see the instructions that we hear. We want to also see them written in the form of text. So we make a rectangle and put it at the top of the screen. Top, parent, top. Left, and so this rectangle will be at the top and it will be from the right to the left. It will be a panel covering the whole top of the map. Okay, and we'll give it a height. And color. Just make it white and give it a transparency so we can see the map behind it. And we want this to be visible only when navigation is active. Great. Let's see if we have this panel now. So we compute routes. We fly to the routes, we select the route, and when navigation is active,
250
there's our
meters,
panel.
turn slightly right.
So now we have a panel here, and here we want to see an icon of the next turn. In this case, it's a right turn, and here we want to see text instructions, which we also hear as a voice. Great. So, since we want to put two elements there, we're going to have a row layout, that they will not be on top of each other, for example. Row layout is not defined, so let's import it. Import quick layouts and just pick the latest one. Great. And now we have it. There it is. We want this row layout to fill the whole panel we have there. And curse fill parent. Okay. And we're going to put a dynamic icon view, which is a general magic type. This type is to draw our icon because we could have a roundabout with 1 or 2 or 3 or 10 exits. We could have a right or left turn that's just slightly right or 90 degrees to the right or more than that. So that would be a lot of icons. So this class can actually generate an SVG file that is custom dynamically generated for the turn that is coming up. So that way we don't need that many icons because we generate them dynamically. And it is also customizable. So first we say layout. And we're going to fill the height. And we're going to say width equals height, so we make it square. And then we customize it. As we see the here the properties, we set arrow inner to, let's say, dark blue, and arrow outer to gold, and the slot inner to gray, and slot outer, we'll just make it the same as arrow outer. There we go. And then of course we need our icon source. Icon source, there it is. That comes from navigation. Current instruction. Next turn dynamic icon. There it is. Okay, so we have our icon. Let's try and see if this works. Computer out. Select the route. Start navigation.
After 250 meters, turn slightly right.
And there's the icon. Great. And now we want to put a text there of the instructions. So the next element is going to be a label. Okay. So for the label, fill width, and give me the font size, so size 16 for example, and the text that's going to be on the label will be a navigation instruction. Let's put a next street name. Current instruction, next street name, there it is. And then we'll also like to have the distance to this next street. So we can have here navigation, current instruction, distance. Distance to next turn, not next turn. Okay. Now this distance is in meters, and we want to show it, if it's more than a kilometer, we want to show it in kilometers, not in meters. So we're going to write here a function. Put here a function. We'll just call it distance, which takes these meters, and it will check return meters. So if it's more than 1000 meters, so it's kilometers, then convert to kilometers. Meters divided by 1000, and don't show more than 3 decimal points. Otherwise, kilometers there too. Otherwise, we just take the meters as is. And we also, in that case, we don't want to show any digits after the decimal point at all. Let's say 0. Okay, now we have our function. And put it here. So put distance great. Now let's see if this works. Compute routes, fly to the routes, select the route, start navigation.
After 250 meters, turn slightly right.
And there's our dynamic icon, there's the next street, and there's the distance to it as we navigate. Great. Now, we see that compute routes and start navigation are both active all the time. Now, while we're navigating, we want this button to not be enabled, and while we don't have a route computed, we don't want this button to be enabled. So let's do that. We go to go up to Map View to our buttons. So here we say enabled. So this is our button to compute the routes. So if navigation is active, then we don't want to compute routes. So we say that we compute routes only when navigation is not active. That is when this button will be enabled. While this button enabled, this is the start or stop navigation button. So we want to be able to start or stop navigation only when we have a valid route computed and selected. So if there is no route, we should not be able to click on the start navigation button. So we go to map preferences, where we put our map route collection. There is main route valid. So if the main route is valid, then this button is enabled. Great. Now let's check that. Start navigation is disabled because we don't have a route. Compute routes. Now we have a route, and now we can start navigation.
After 250 meters, turn slightly right.
We started the navigation, we cannot compute the routes because we're navigating. Great. Now, let's see if we can get this to work on Android, and how difficult that is, and what code changes we would have to make. So we go here to projects, and we see the desktop Linux is selected. We'll select Android instead. select build, go here. Now this ARM-ABI v7a is the 32-bit Android, this is the 64-bit Android device. But in this case, we are going to run it on an AVD. So here's the virtual device, x86-64. So let's try that. There's the device. It's building. Deploying, and there it is. Compute routes, it flies to the routes. We can select a route and we can start navigation. When we start navigation, we see only the route that we selected, and we see our dynamic icon of the next turn. We see the name of the next street, and we see how far away it is, and we see that the dynamic icon changes. Great. Now let's see if it's possible to put this on Raspberry Pi, and how difficult it is, and what code changes we have to make to get that to work. So what we want to do now is copy the General Magic QML plugin to the Raspberry Pi. So first we connect to the Raspberry Pi here. Okay, so now here's the Raspberry Pi. We go here to the home directory, to Pi, and here we want to create a new directory just for our project. We'll call it QuickNav. There it is. We go back to our local machine, and we want to go here to Qt 5.15.2 Linux ARM64, and here is the General Magic QML plugin. There it is. So we want to copy this to the Raspberry Pi. It's copying, and that's it. It's copied to the other side. Now we also want to copy, of course, our project, which we just wrote just now. So we go here to projects where we saved it. There's QuickNav, and there's MakeQML. We copy that too. And there it is. Great. We check QML, General Magic. There's the plugin, and there's our project. Good. Now we have a video capture from our Raspberry Pi. So we're going to show it. There's the Raspberry Pi. We go here to the QuickNav directory. We show it. So there's our project, and in QML we have the General Magic plugin. There it is. Great. So it is outside the scope of this presentation to show how to cross-compile for Raspberry Pi or how to compile on Raspberry Pi. We don't have time for that. So we're going to use a QML scene to run the project here. There's QML scene. This minus capital I, a command line parameter there, gives the current working directory. We're inside our QuickNav directory, and we say current working directory pwd/qml, because that is where we put the General Magic QML plugin. So we need to tell it where the plugin is, because our project uses types from that plugin. And then at the end there, main QML is our project. So now we're gonna start it and see if it works. Great, it started. We can have panning, we have zoom, rotation. Great. We see that our start navigation button is not active because we don't have a route. So we compute routes. We fly to our route, we can select the route that we want. Great. And we can start navigation on the route. Great, it works. Thank you for your attention, and we'll continue in a few moments with a Q&A session.
Well, thank you very much for that. That was great. Licensing. If I was to use this in my project, what do I have to know about licensing for this?
Well, you need to go to generalmagic.com. There is a free trial. For instance, you can have each month about 50,000 hits for tiles or searches or route computations like that. And then after that, it's $0.5 for each 10,000 hits or something like that. I don't know. So go to generalmagic.com and you have all the prices there.
Gotcha. Map providers. So if I'm assuming this has got its own map provider, right? Because it's its own view. If I wanted to use this with like Google or OpenStreet, is that possible or not?
Justine?
The data is OpenStreetMap data that we're using. Yes.
And with this, that's the option. That's what you use.
Yes, we have OpenStreetMap data, and the maps are built also using other open source data, like for elevation or satellite imagery, which are from Sentinel, and so we use various sources for open data sources.
Great. Well,
I also like to mention two things here. The plugin is in technical preview right now, so we are looking for feedback, and please don't be a stranger, drop us a mail. And also the macOS and Windows platform are in the works. They will be soon available. So right now only Linux is available.
Gotcha. Is there this? I saw that we had that's on Raspberry Pi. Is there any support for Yocto or anything like that?
Well, you can put it on any framework you like. You can embed it in Yocto or in Buildroot. It's up to you. We give the plugin, and it's up to you where and how to use it. We just showed the Raspberry Pi because it was easy, and we actually had a Debian Bullseyes on that Raspberry Pi, and we just started. We copy the plugin from the host to the target, and it just worked.
Great. Does it support Qt or Qt 6?
Not yet, because we still need some modules from Qt that are missing in Qt 6, like multimedia, for instance. By the way, this plugin is not based on Qt location or stuff like that. It can use parts from Qt location, for instance, the position provider. If you have a position provider, you don't need to rewrite that. You just link it to this plugin. It's a standalone plugin.
Gotcha. What's it using for rendering? OpenGL or?
Yes, it's using OpenGL ES2.
Okay.
So, which is a subset of OpenGL for embedded devices and for Android phones.
And the map view, it's actually a texture, so you can put it on other tough. For instance, you can mix it with Quesa or Qt3D or any other technologies.